Alright, welcome back to the classes slides. So let us continue where we left off. We made a point class, and we implemented a bunch of operations for points, and we talked about how some of those things execute. So let's continue and make a better version of that previous implementation. Okay? So what I did last time, let's copy the code from last time into today. That was classes.cpp. Let's just put it here, and let's look at it. Because something I did was I implemented the methods inside of the class, which is kind of a no-no for C++. Okay, so that is not good style, but it does work. Okay, so we're going to try and move them out of the point class. Because it would be nice to split up the declaration of the class. Does this sound familiar? Like what it has, what it contains, from the implementation of the class, how it does its work. Okay? So we'll end up with a .h file that contains the class declaration and a CPP file with the class implementation of all the methods. Okay? So that works, and you can even split things up in the same file. That's what we'll do first, I guess, and then we'll get into fancier things. So, yeah, let me show you how to move all of the method implementations outside of the class and to separate it into a declaration and an implementation. Okay, so I'm going to move all of these methods outside of the class now. Okay, but I still want them to be defined inside of the class. So I'm going to do this. I'm going to say void negate just like this, and say that it exists, but not give an implementation for it. So I'll do that for add and for scale as well. So here's how you declare the point class, but not implement it yet. See that? So that's how that works, and I think it seems to be happy now. So these are method declarations now. The implementations will come later. This is the point class declaration now. It says what's inside of it and the methods that exist, but it doesn't say how to do them. And that's quite nice. And then we can move those methods outside. But when we move them outside to C++, these just look like normal functions, right? They're talking about x's and y's that don't exist anymore. We need to tell C++ that no, this is not a negate function, it's a negate method that belongs to the point class. It's this one that was declared up here, okay? We have to do that. We have to tell C++ which class our method belongs to, if it belongs to one, and so it gets a special name. We put the name of the class and 2 colons in front, and that's the better, more precise version of that method name, okay? So instead of saying that this is a negate function, it's a negate method of the point class. It is points negate method, just like that. The point : you read as, or the : part, you read as like apostrophe s, just like standard : This is the negate method that belongs to the point class. And so now it's like, oh yeah, I know what x and y are. They're part of my point object. Cool. So this is the full name for this method. We need to add it now, is point : add. The full name for this method is point : scale. We say that this is not just a function, it is a method of the point class. It's points scale function, or scale method. Okay? And so now everything is going to work as it did before. Now it's going to compile, now it's going to run. Okay, so declaration and implementations of all those methods. We got to tell C++, this is not a normal function like you think it might be. And it does the exact same thing. It all still works. Okay? So yeah, read that : as apostrophe s, and it should make enough sense. Another lazy thing that we did that was not correct C++ was we did not really care too much about this thing called access control. Okay? We want to care about that. I think you can imagine that because there's a public, there's also a private. So let's talk about what private means and introduce it into our class, okay? When we say public, when we say something is public, that means we give access to that thing to anybody who is trying to use our class, okay? If we use public in our class, we give complete access to outside of the class implementation. Anybody who's trying to use our stuff, they can, okay? Anything after public is visible to the user outside of the class's implementation. So that'll make sense once I talk about what private means. So for example, right now, let's go back to blue. Right now, in my main function, for example, I can make a point, and I can directly set p's x. Yeah? I'm allowed to do that. That is something that I can do. That is now, this is accessible to me as the user outside of the point class implementation. Accessible. Okay? We are able to just willy-nilly change these x's and y member variables because they are public. I'm allowed to go down here and set them. We don't like that. Okay? That is not nice. Sometimes we don't want our users to mess with some pieces of our class's stuff, especially the member variables, okay? That is not something that we want sometimes, and so we can mark those things as private, which makes it so that this code will not compile anymore, so that we cannot set p's x just like that. You have to go through some other means. And there's plenty of things that we want to keep public. Maybe the only way that x's and y's should be changed is like through negate, the negate method. That's a public method. The user's allowed to use it. We don't want the user to be able to set the member variables, though, usually. Okay? Those should be private. So, yeah, the goal is make private anything that you don't want the user to touch. All right? So we'll do that in just a little bit, and I will hopefully remember. Okay? So, let's see, what do I want to do now? Let's keep on going. I would like to, before we get to testing the point class, I think I would like to split up the class declaration and implementation. So we're going to make a little library for ourselves, a point library, okay? So, yeah, if we need a point library, we need a point.h with our header file guards, and this is the declaration of the class, okay? So that is what goes in the header file, just as usual. It's declaring what exists, and then the implementation is in the corresponding .cpp file. I call it point.h, so I'll call it point.cpp. And so this is going to hold all these implementations. Whee! And so this is actually the reason why it's customary to include the name of your header. Right now it doesn't know about the point class because that's declared in the header file, and so we have to include it here. Okay, and now it's happy. So this is point.cpp, the implementation of everything, and we'll just leave the rest in classes.cpp. That includes our point library. Okay, there it goes. So now everything is contained in multiple different files. So we have point.h, included by our classes.cpp file, and used, it's using all those things, and then we have point.cpp that implements all the stuff defined in the point class, all the methods. Okay, so these are all working together, and to compile as normal, you give all the .cpp implementation files. So I have to give that now. And now it still compiles, and it still runs. Okay, so that is nice. That is all still the same, and now I think we're ready to test. All right, so let us test our implementation of the point class. Won't that be fun? So to remember, what does it mean to test? Well, we write a tiny little program that we know what is supposed to happen with, and we check that those things that were supposed to happen, that they actually did happen. Yeah. So we kind of run the program in our mind so that we know what should be taking place, and we confirm that it did with an assert true, for example, okay? Because then you know what it should do, what to expect, and then you compare using assert true or maybe something fancier. Like you compare what you got back, what actually happened, with what you expected to happen, okay? So let's bring in a assert true function, and let's test our negate and scale methods for the point class. For example, here's a test for negate. Let's make a point p. Let's set its x to like 42 and its y to, it's supposed to be an equals, its y to 43. Eventually we're going to make it private, so we can't do this anymore, but don't worry, we'll get there. And then we're going to call p.negate, and what should have happened, right, if we compare and look at p's x and y, it used to be 42 and 43, right? 42, 43. And now, after negation, after negating itself, it should be negative 42 and negative 43. Yeah? That is the goal. So that's where we want to test our stuff. So we'll make like a 4-line testing function and then assert true that p's x and y are those proper values. Okay, so that could be a negate test. Let's make that happen. So let's make this one window again. And I'm going to need my handy dandy assert true. So let's go and find that. Let's steal it from somewhere else. I don't think I used it that time. Let's maybe count words. I like to put it here. Yeah. So assert true. There we go. So here's my nice assert true. It uses strings, so let's include the string library. And now instead of all this, let's make a negate test. Let's comment all this out. And so we'll do a test negate function. And that will run this test that we were thinking of right here. So we'll make a point, call it p, set its x to 42, and its y to 43, and then we call p.negate, tell the point to negate itself, run that negate method, and then we want to assert true. So what should have happened is that p's x should now be negative 42, and p's y should now be negative 43. I'll just call it something like negate, and that is a test. Does that make sense? And it should pass because we implemented negate properly. And so that's a good test. Let's make a test also for scale. Let's steal this a little bit. Just testing that scale did the proper thing. So let's call it point q this time. So q's x, let's make it be like, I don't know, it's supposed to be doubles, right? So 2.5 and 3.5. And let's scale the point q by 2. Scale by 2.0. And so now the values for q's x and q's y, right, should be 5 and 7. Remember that it is a bad idea to compare doubles for equality, but this is one of those do as I say, but not as I do moments, okay? It will work this time. So scale. And so that should be, oops, I need to run the test actually. And it passes, yay. So this is just an idea of what we want to have happen. Like I want to scale this point with these exact coordinates by 2. I know that that should make the point 5 and 7, right? Because that's double each of these. And I check that, and that's my test. Make it pass. Okay, so that's testing. And now that we're on the same page with that, that's just how to test a class now instead of just a bunch of functions. Not too bad. How to test a method instead of just a normal function. So with that, I would like to introduce even more terms today. Sorry. So let's get philosophical and talk about how we want our programs to exist and be interacted with. So I have my classes, and I would like to, or I noticed, to just make classes in the first place, I noticed that I wanted to take my data, like I had in a struct, and bundle it together with some methods that operate on that data. That's a nice idea that we discovered that we would like to have. Okay, so when we do that, when we make a class that has methods as well as fields, we have points, for example, not only holding on to concrete data like x and y, but also they know how to negate themselves, how to scale themselves. So every single point object that you make looks like this. It's a box that holds an x and a y. It saves its own version of that. And then it also knows how to negate itself, like that's part of the box. How to scale itself, that's part of the box. How to add itself to some other point and give back a new one, right? So that is called encapsulation. That's one of those nice pillars of object-oriented programming. It's something that we care a lot about, okay? So that's called encapsulation, that process of bundling data with operations, fields plus methods, okay? And then we have information hiding. Now we're ready to get into the private stuff. So what this means is we don't trust the user. We would like the user to only be able to see pieces of the class that we let them see, okay? Only the public stuff, that is. We are allowed to do that. We are allowed to section off pieces of the class that are just for us as the class implementors, okay? Everybody else, everybody who wants to use our class, does not get to touch those things, all the stuff that we mark as private. And the point of that, the point of having private things, is so that the user doesn't need to care about the implementation, as long as it works, as long as it makes sense in their mind. You can change a method to something that's better, that's faster. As long as your public methods still do the right things, nobody cares. Nobody's going to get angry. They will praise you, right? But if everything was public, maybe your faster implementation breaks somebody's use of that silly, weird method that is being used to implement that silly, weird method, okay? So that is my best example of that, but I'm going to show you private now, and it should make a bit of sense. We don't want the user, for example, to have access to our member variables. So, like this. We don't want the user to be able to set x and y. No thank you. We don't want that to happen. So that is defined here in point.h. I would like to keep all of these methods public, but all these fields are marked as private, okay? So private things are not accessible outside of the class's implementation. Okay, so when I mark this as private, I'm totally allowed to use x and y in the methods, because that's part of the class. I need those in order to do stuff. But outside of it, like in just a normal function, in the main function, I can't set x and y anymore. The user is no longer allowed to do it, which will mean these tests aren't going to work. This is not going to compile. It's going to say, not allowed to access x. It's private. Let me show you that. So here's an example for y. Like I'm trying to access q.y here, but sorry, that's private within this context. I'm not allowed to access it. Isn't that nice? So I can section off pieces of my code that I do not want the user to touch. That's quite nice. So we just did that. That's called information hiding. All right, and with that, I think we're ready to remember that we already know all of this. We've used strings, we've used vectors. Now you know all the fancy terms. You have used the .at method on strings, for example. It is a method. You have used the .size, the .pushback on a vector. Those are methods. And nobody anywhere in the documentation showed you the body of that size method's implementation. Nobody showed you that. They just showed you how or what you can expect when you call it, right? That is all you need as the user. There could be many private things, many private fields, many private methods even, to vectors that talk about how they themselves are implemented at a very low level. You as the user do not get to know about them or care about them. Okay? That is classes in a nutshell. Object-oriented programming, encapsulation plus information hiding. And now we're ready to change the way that we do things so that we can still set the values for points, but in a better way, without having to use the dot and get exactly those values of the member variables like that. That is a bad strategy. Okay, so let's get fancy, and what is all that? Let's talk about how you can do this, a way to fix this, a way to access the X and Y fields now, because we still need those. Like, we want to change them. We want the ability to change X and Y and get the values of X and Y, but not this way. What is the better way? You can make a method that gives back the value of your member variable. So instead of, and I promise this is useful, instead of saying point, making a point P and saying P.x equals 42, instead of that, you'll make a method. Not allowed anymore. Instead of this, you'll say P.setX, for example, and set it to 42. And this is much better. The reason why making a method to do this and not allowing this is much better is because maybe you have conditions on your member variables. Maybe you don't want ever to make a point with an X value that is negative. If you allow the user to access that data, that underlying X value, that member variable, they can set it to whatever they want, including negative things. If you make a method, you can, in the body of that method, choose whether or not you want to set that X to what the user passed along, because you know better. That is the key of these kinds of methods. These are called setters, okay? And so to set things, we'll make setters, and to get things, we'll make things called getters or accessors, okay? So once we restrict access, once we use private on our member variables, which you should always do, you have to add some public methods to retrieve and modify them, things that give back the value, so getting the X and getting the current value of the Y member variable. Those are called getters or accessors. And then things that set the value, like this one, those are called setters or mutators, because they mutate the object. They change things inside of it. So getters give back the current value, setters set the value to something new. And that gives you very fine-grained control over how those values change and how they are shown to the user. Maybe there is no X member variable. Maybe you're storing polar coordinates, if you know what that means. You can still make a getX method that converts it to normal XY coordinates. That is food for thought. But let me show you how to make this, because this is going to allow us to do cool stuff. So in the definition of the point class, here's what I'll do. I will make getters and setters. Getters, setters. So here is my getter for X. It gives back the current value of X. X is a double, so it's got to return a double. Yeah. Get X, here is get Y, and then we'll have setters, set X, and set Y. So set X to a new double that I just passed along. And then set Y to a new double that I just passed along. And these we will go and implement. Are you ready? So I'll do this down here. So let's get these on a normal level and implement them. How do I give back the current value of X for my object? It's return X. How do I give back the current value of Y for my object? It's return Y. But remember, the name of this method isn't getX, because now it looks like a function. It is point, get X. Point, get Y. Gotta remember that. Boop, boop. And same for setting. If I want to set the X member variable, well, I'm just going to set it to whatever's passed along. X equals D, Y equals D. That changes things. So these give us control over how our users get to interact with our private member variables. That is the goal. So now let's change everything in the program in the main function. Oops, sorry, my other computer's sound was so loud. Let's change everything here, because this is us as the user using our point class, let's change everything here to use those getters and setters. So this is trying to set the x, so we'll use set x. P dot set x to 42. And this is P dot set y to 43. Okay, and then this is getting back the value of x, so it's get x. And then this is getting back the value y, so get y. And then I'll do the same thing for scale. And then I want to get back that x value, so get x and get y. And now let's go back and, capitalize them. So that should, in theory, be happy, because these are public methods again. And now, yay, it does compile. And our tests pass. Now we're setting them in the cool new way, using getters and setters. All right? Now, let's talk about const, because I'm not finished with const, actually. We talked about it in terms of functions, in terms of normal variables. There's more to it, actually. So here's the const that we know about for parameters of functions or methods. You just put it next to the parameter, like, okay, now I'm taking a string as a constant reference, which means I'm not allowed to touch s. There is an equivalent thing for when you have a method and you don't want that method to touch your member variables. That, I guess I should just say member variables in general. When you don't want it to touch its member variables, you say const. But not here, because that modifies just a single parameter. You actually put const after this parenthesis, which sounds weird. But that marks it as that method does not, or it's not allowed to touch any of its member variables. Doing so would have been a mistake, and so we're going to make sure we're not allowed to do that. So you put const after the method's name, weirdly enough. And this is quite nice for when you're trying to test things and make sure that your code is correct, because once you see const after the name of a method, that means it's definitely not going to touch its member variables, and that's one less thing for you to check in your tests. So something that is very commonly const is a getter. Getters should give back the values of member variables, right? They just return x, return y. They should not be setting x. No, we don't want that to be allowed. Right now it is. So let's make sure that doesn't happen by putting const after it. So instead of saying double get x, and then a semicolon right here, you say const after it, which looks weird, I know, but that's how it works. And this is now called a const method. It's not allowed to touch its member variables, which is exactly what we want for getters. So let's do that. So we say const here, and also, oh, sorry, no, that is the right place, excuse me. Const and const. And now, this is not even allowed to compile because all the member variables are off limits. Isn't that nice? Boop. Assignment and read-only object. So apparently, as far as C++ is concerned, the current object becomes read-only. You cannot change anything. Cannot set the value of any field in that object. So that is no longer allowed. As it should not be allowed, right? So now, compiles, still runs, but we have more guarantees as to what these methods should do. And now let's look at our other methods as well. We have add and negate and scale. Should any of these be const? Let's think about that. Well, negate changes x and y, right? Let's go to the implementations. Negate changes x and y. it needs to be allowed to change those fields, right? Same with scale, it changes x and y. But look at add, it makes a new point. It does not change the current objects x and y, so it can successfully be marked const. And you got to do that in both places, so const. And now we're not allowed, again, to write like x equals 42. That is beautiful. So again, not allowed. And it's still going to work just fine. And we have very strong guarantees that we are not allowed to touch anything once we're inside of this method. All right, so that is very important stuff. So we talked about const, we talked about private, which allows us to mark some things as not available for the user to see, like our member variables. Member variables should always be marked private. And then once we want to use them, or if we want to use those member variables now, we want to control how they are used with getters and setters. Okay? Getters should be const. So I think that's everything that I wanted to talk about here for my big long point class implementation. So that's const at the end. So we have done many things. We've gotten very fancy. So now, in the remaining time, I would like to have you work on these things, and I would give quite a bit of time in class to work on these, so please definitely pause the video and try them out yourself, maybe code them up if you need to. Here's what I'd like you to do. So fix this class definition according to what we talked about in this lecture. This should look wrong to you now. Let's fix it. So here's a blah class. It looks like it has 2 methods and 1 field. Rearrange things and make them better. Okay, so give that a try. And now that you're back, let's talk about it. So here is a field. That better have been private, right? All of our member variables should always be private, not accessible outside of the class's implementation. And then here are 2 public things. They're methods. They're allowed to be public. But what else could be wrong? We have getters and setters. So setters need to change things, right? So they're fine the way they are. But getters should not be allowed to change any of our member variables. We only have one in this example, but it's an important one that should not be allowed to change by something called getX. So this better be marked as const. Did you get that? So those are the 2 things that should be fixed here, according to what we have talked about today. And so that's my first example for you to try. And then here's a more involved one. Definitely take some time, maybe code it up, print out things, write a test even. There's something horribly wrong, and also very subtly wrong, with this reset method. So here's a point class, and let's say we add a reset method to it that's supposed to like zero out everything. It sets the x and y fields to 0. There's something wrong with it right now. So see if you can figure out what's wrong and explain it in words even. So definitely take some time to try that, and then I'll talk about what's going on. So let me show you this. I think there's enough time to like try it out and write a test even. So here's reset. Let's add it. This is from the crushed ice. So here's reset. It is points reset, right? Again, from the crushed ice. And here's its implementation. Double x equals 0, double y equals 0. Why is that wrong? And it looks like there's something weird going on with the spaces. Sorry. That's what I get for copying and pasting. It has weird Unicode characters. I believe it is happy now. So here it is. Point reset. Point just reset just like that. So that should be okay. And here is another example of spaces not working. So now it exists, and here I am implementing it. And so it should compile, should be happy. I don't know why it's underlining it right now, but we'll get there. It totally compiles. I think if I change something ever so slightly and resave it, then it'll fix itself. Okay, now it's happy. So this is reset, and it's not working. What should it do? Let's write a test for it. Let's just reuse all this. So here is q, let's say q.reset, and so it should hold 0 and 0. Because that's what should be being set into it, right? And let's see if it works. Oops. I need to change this to have a real name, test reset, and then I can call it like I did here. And it totally fails right now. And let me show you why. What is q's x and y right now? See out q.get x, and then a space, and q.get y, and a new line. It's still 2.5 and 3.5. So this implementation right here is not changing the value. What is going on here? And so look at these setters, because reset's supposed to be setting things. What's the difference between this code here, these two methods, how they're doing things, and how this method's doing things? Do you see what is different? It's these types, double x, double y. Those are the mistake. When you say double x and double y, you are making brand new variables. Did you catch that? That's the secret. And they have more priority over the existing member variables, because you just made these. Surely you wanted to talk about those instead. Okay. These are brand new variables, and they shadow your existing member variables of the same names. So making x and y does nothing to your member variables. So let me show you what's happening with a stack. So I was in main, which calls test function, test reset, which makes a point q that holds an x and a y of 2.5 and 3.5, and then we called reset, q.reset, which is just a method. It's similar to a function that's still getting pushed on the stack, so we have reset, and instead of having x and y inside of reset, as they normally would be the objects x and y, no, you just made you just made brand new variables called x and y, local to the reset method. So here's x set to 0, here's y set to 0. It did nothing, and once this returns, these goes away. Those go away. It did nothing to q. It did nothing to q's x and q's y. So these make brand new local variables. Local bars. Crazy. So this is a very common error. It will come up. Just look out for it, okay? So these make brand new variables. These change existing member variables. Yeah? So just keep that in mind, and all will be well. So I think that is officially everything that I wanted to talk about today. So we talked a lot about how to write good classes properly. So we separate the declarations from their implementations, we test them well, we hide things from the user, all the things that they don't need to see, like the member variables. And once we do that, we have to add getters and setters, and we also want to, as implementers, keep ourselves from doing silly things, so we mark our methods as const when we can, when it shouldn't be the case that we can modify our member variables inside of that method, when that does not make sense, like for getters, okay? And then we talked about some errors that you could have. So that is everything that I wanted to talk about for this lecture. We'll finish up classes next week in those lectures, just one more, I think. And that is all I have. So I'm going to release your next lab, not this week, but next week, because we need these last few slides, I have decided. I realized we need these last few slides to be able to start it properly. So I'll see you then.